Welcome, guys. Welcome to the second session of the Cairo Bootcamp for that's for week 5. Yeah, at the last class, your tutor Casweeney went through components and components and composability in Starknet. So today is going to be going through. You guys are going to be writing token sale smart contract. Is going to be guiding you on how to write a token sale smart contract, and also how you can upgrade your smart contract, right? So yeah, that's it basically. So if you have questions, please do not hesitate to drop them in the chat box as it proceeds. So you can always visit your questions from time to time. Without wasting time, Casweeney, please, you can take over. Thank you.
All right. All right. Hello everyone. How are you doing? I'm sure you're ready to fire down today. So today's class, we won't be making use of slides. And for some reason, I have a very strong feeling that today's class might exceed 2 hours a little more. Let me just try and see if I can show my time management skills and all. All right, so before we proceed, let's see, how many persons were able to read the one I mentioned that you guys should read, like, so that you get to understand how composability works and all of that. Like, if you know you read the article, can you indicate in the comments in the chat or something? Nobody? Okay. All right. I went through it, but couldn't complete it before the class. I went through it. Okay. So for Hamid, like, you say you went through it, like, what did you get from the article? Just just give me what you got. Like, I want to know because I know that if you read the article, like if you read the article completely, you will know how composability works and how to create components. But I just want to know is it that you scanned through it, you didn't really read it to a particular place or something? I want to just get Mujid as well. Say you went through it. Okay. Let's just proceed. The reason why I was asking is because I have a bounty for anybody that actually read the article and could, like, but since nobody read the article, so let me keep my bounty to myself. Okay, let's get to the class proper. All right, so today's class, we are gonna be doing 3 things, which is we are going to create an embeddable. We are going to create what is it called again? Sorry, let me just get the name. An embeddable implementation, and we are also going to create a component. After we do those 2, that's when we are going to write our token sale contract and upgrade it. So I'm gonna be moving pretty fast. Yeah, I'm gonna be moving pretty fast. So if maybe while I'm moving and you get confused, please type in the chat section. I can see everything. My screen is here and I'm coding on this other side, so I can see everything. Once you type in the chat, I'll see it straight up. All right, so without taking much of your time, let's proceed. Now I'm gonna share my screen here. Let me quickly do that. So share screen, entire screen, and share. All right, if you can see my screen, kindly indicate. Sorry. Okay. Great. All right. Okay, so today we are going to go straight into business. No need for slides. Desktop, Cairo Bootcamp. So we are going to start with this guy. So the first thing we are going to do now is to create an embeddable implementation. So I remember I said that embeddable implementations are the building rock of components. So if you understand how embeddable implementation works, the whole component thing will be easier for you and all. Sounds like you might have to switch to a different language. Please obey, cancel, sorry. All right. So let me create a new guy here. I'm gonna say call it embeddable. Sorry, let me make this bigger so you guys see my screen. Yeah. Scarp embeddable implementation. So this is like a short form of implementation. So I'm creating a default Starknet Foundry project and wait for it. So that's been created. I just open this guy and get it. So what I'm doing now is just to teach you guys how to create your own component. You know, it's one thing to know how to use components, and it's another thing to be able to create components. For instance, let's say you have a smart contract you've written and you want to turn that smart contract to a component so that you can embed that smart contract in another smart contract. That's what I'm teaching you today. So you learn how to create your own components, not just using other people's components. All right. So, yep. The first thing we're gonna do, let me make this guy bigger. 1, 2, okay, 2 is okay. All right. So I'm gonna open this guy and I'm gonna get rid of all of this. So what I'm gonna do is very, very simple and straightforward, like very, very simple. And the way you create embeddable implementations is quite similar to how you create smart contracts. So let's do that straight up. I'm gonna do this guy. So I'm gonna say Starknet interface. So this is you guys remember this. This is the attribute. So I might call this attribute sometimes. I might call it flag sometimes. So this is the attribute you use to tell the Cairo compiler that the code below it is an interface. So you basically use traits and to create an interface. So I'm gonna call this simple. I'm gonna call it simple traits, right? So, and this is going to take a generic. I'm sure, is there anybody that doesn't know what a generic is? If you don't know what a generic is, just type it in the comments in the chat. So I'm sure you guys are following. So contract states, right? Okay, I don't. Okay. Who else? Only you, Mojid. Okay, only you, Mojid. All right, I'm gonna explain that. Okay. So I'll say fn. Let me just create a simple a simple function named return number. And this return number is just going to be a function that is reading from state. So it's going to take a snapshot of the contract state. I will explain that guy for you. What's the best way to explain this stuff so that you understand? Okay. All right, it's gonna return, let's say it's gonna return U8. Yep. So this is an interface. What a generic is I'm thinking of the best way to explain it. So let's say Cairo is a static type language, just like TypeScript and Rust and many other languages that are statically typed. Now you have a function, and let me quickly play around something. Can I do this? Function take number, right? Is there float in Cairo? Okay, let's see. I'm not sure. Let's see. So function take number, right? And it's going to return, let's say, num1, num1, and this is going to be, let me see if there's float. F. Oh, there's no float, there's felt. Okay, I get it. I'll use felt and num and u256. So let's say this is a u256 guy, right? And you want to return u256. Okay, and you now say this is 6. So you're returning 6. Please pay attention, Mujib. Now, this function is taking a number, right? But you have told this function that you're taking a U256 number. But you know that felt too can also be regarded as number. What if someone wants to pass felt in this same function? Now, this function will not take felt because you've told this function that the only type of number you should take is a U256. So if you want this function to take in any number, irrespective of the type of that number, what you do is you make use of what we call generics. So if it's in Rust, I know how to do this in Rust, so let me see if it works here. So I can do something like T here, and this will take T here, and this will return T. So yeah, so this is it. So this is what a generic is. So this is going, so let me see if this works. No, it's not gonna work. Okay. So this is what a generic is. What I did here is, I just said, take number, I make use of a generic, and this number will be any of this. So if maybe I'm passing in felt here, whatever I'm passing in here is what is going to return. Like that type is the type it's going to return. If I'm passing in uint 8, which that means this function is going to return uint 8. If I'm passing it a float, that means this function is going to return a float. If I'm passing in a string, that means this function is going to return a string. That is what generic is. But by the time you specify the type straight up in the function, you will not be able to pass any other type unless that particular type is specified. But when you make use of generic makes the function generic. So I don't know, generic makes the function able to accept any type you pass into the function. So that's what generic is. So that's basically it. I don't know if my explanation did justice to it. Yeah, Mojid, you. Yeah. Generic makes now clear to me. So what T contract state? T contract state is a generic. That T in front of the contract state is a generic. It could be anything. But the reason why we call it T contract state, we are just using that name to let ourselves know that, okay, what we are mostly expecting to pass here is the contract state. But it can actually be anything. Does that make sense? All right, let's fire down. So I'm getting rid of this guy. I've not done this kind of manipulation in Rust before. This is the first time I'm doing it. I'm just like using Rust knowledge. I've not done this manipulation in Cairo before. Yeah, I'm using Rust knowledge to like try to do this. Okay. So we have our return number. Now let's go down to creating our embeddable implementation. Now remember that, let me take your mind back to why we are creating embeddable implementation. Embeddable implementation is the rock, this is the rock behind components. So anytime you're embedding any component, what you're actually embedding is that embeddable implementation. You're only importing the component and connecting to the component. But when you want to embed, what you embed is that embeddable implementation. So let's create the embeddable implementation. So we are going to use this guy, and we are going to call it Starknet embeddable, right? Embeddable. Yeah. So we'll call it Starknet embeddable, and we are now going to create the implementation block for it. So we'll call this simple info. So this simple implementation is just like the name we want to call this guy, and we are going to create this guy here, and we are going to create a generic of T contract state here. So we now say off. Now, whenever you're using off, so I explained this the other time. So I said, in other languages, if you want to inherit an interface, right? For something like Solidity, you do something like contract. The name of the contract is the name of the interface you're inheriting. Now, what you're doing here is implementation, simple implementation of that. Of there is serving the purpose of if in Solidity. So you're telling it that you want it to implement this simple trade. So, and whenever you're using an interface for implementation, it means that interface is going to guide what the functions you're going to write in your implementation. Example, if you tie this interface to this simple implementation, you must implement the functions that are in this interface. So let's go. I'm using English. See, English is not my mother language. So let's just continue. All right. So I'll say simple traits, right? Sorry, simple traits. And I'm going to pass in this guy here. I'm going to pass in the contract states here. Now, this is where we are actually passing the real stuff. Here we are making use of generic. Here we are passing the real stuff. So this guy is complaining. That's because this guy is not in this scope. So we are going to make use of super, right? Super should be the guy. Yeah. So let me maximize this stuff. So once we do this guy is going to complain. Super cannot be used. Wait. Sorry. Let me see why this guy is complaining. Trait not found. Are you kidding me? Starknet interface. Trait, simple trait. Oh, I see. Spelling error. All right, yeah, that is good. Contract state, type not found. Contract state, type not, see contract state, yeah. Okay, all right, we're good. Okay, so now let's implement the function. Function return number, taking in self, and we are using at the contract state, right? And this is going to return U8, right? And what we are basically returning here, let's just return 8. So now we have created our embeddable implementation. This is our embeddable implementation, very simple. So this is similar to, let me show you guys. This is similar to this guy. Packages. Let me go to tokens. Let me enter source, go to ERC20. No. Source ERC20, yeah, that's 20. All right. So that stuff we just created is similar to this guy you're seeing here, this implementation you're seeing here, right? That is what we just created. But I'll show you the difference. The reason why this one has embeddable as is because it is inside a component. The other one we didn't use embeddable as because it's not inside a component. So you're putting embeddable as in this one so that when you import the component, you can use this name here to embed it. All right, so let's move over to this guy and let's use it and see what happens. So now let's create a contract. I'm going to do this guy. I'll say Starknet : contract. And inside this contract, I'm going to say mode simple contract. And it's going to be this guy. And this contract is going to have storage. And inside storage, I'm going to say struct storage, right? Struct storage, and I'm going to open it up. So I don't need anything here. What I just want is to make use of this guy. So what I'm just going to do, I'll now say implement my simple info is equal to, I'll now do super : this guy, simple implementation. And this is where I'll now pass my contract state. And that's all. So now let me explain what is happening here. I can call this any name. I can call this CAS contract implementation, or I can remove the implementation and leave it like this CAS contract. So with this now, this guy you're seeing here, this is like the embeddable implementation that is outside. I've just created it, but this is my contract. All I'm doing now is I'm embedding this embeddable implementation inside my contract, and automatically embedding this, I have access to this function. I can call this return number function straight up. So if I want this return number function to be available in this contract, all I just need to do is say hash in bracket ABI into embed underscore v0. Yeah. So this attribute makes all the functions in this stuff we just embedded publicly accessible. And this is everything you need to understand about embeddable implementation. Any question? Please ask question, so that at the end of the class, some of you will not keep quiet. Are you guys following? If you're following, let me see a yes. Okay, is this the contract component? No, this is not. See, this here now is a contract. Please, guys, try joining class early enough so that you won't get confused while we proceed. Now, this here is the contract. I'm teaching you guys how to create embeddable implementations. Remember in our last class, I mentioned that embeddable implementation is the building block of components. It is embeddable implementation that makes component what it is. So when basically what you do, component is just a container that has one or many embeddable implementations. So which means it's just like embeddable implementation is just like a block that holds the function inside a component. So component is just the container. Embeddable implementation is actually the stuff you're embedding in your contract. So if you understand how embeddable implementations work, that is the starting point to understanding how components work. So this stuff we just created, now if you notice, we did not use components here. We just created a trait, which is an interface, and we created an embeddable implementation. This embeddable implementation has just one function that returns 8, right? Now, this embeddable implementation, see where we are embedding it into this contract. As you see this contract now, this contract has this function. You can call return number on this contract and it's going to go because you've embedded this stuff here. And if you want to add more functions to this contract, you don't even need to do it in the contract. You can just come here and add another function. And the more functions you add, let me just add the interface, fn get name. Yeah, let me just call it get name. And get name should just say self into at the contract state, right? This should return byte array, right? Okay. Now we see these guys complaining because we have not implemented this function. So I'm going to just pick this guy up, put it here, right? And this should return a byte array. And I'll just say Casweeney Ojuku here, right? Now, adding this function here now, this function is available in this contract because we have embedded this embeddable implementation here. So any function I add here automatically is in this contract. Does it make sense? Yeah, DK, you can catch up with the videos for the previous class. Hello, does this make sense? All right. So embeddable implementation are like libraries. Oh, will I call them libraries? I don't know if they are libraries. What are libraries again? I've forgotten. I don't know if they are libraries, but the general picture of it is just see them as, see, this is a block, and this first block, watch what I'm doing. This first block is components, right? And inside this component block, you now have blocks with function. Now, this block is embeddable implementation. And you can have as many embeddable implementation as you want inside a component. So you can have another block again with function. And this is another embeddable implementation too. So you can have as many embeddable implementation as possible inside a component. But now we have not started talking about how to create component. I'm just showing you guys how to create only embeddable implementation, which is what we did here. So if you look at this flag, it is Starknet embeddable, which means this thing can be embedded in a smart contract. So that's what that means. You cannot deploy it directly. To use it, you have to embed it. And this is how to embed it. There's a name this syntax is called, and it's in my article. I can't remember. I know I wrote about it. There's a name that syntax is called. Let me quickly check it out. I wrote about it just for a moment. So here, embedding internal function logic in the contract. So can't find this now. I can't find it now. Let's just continue. So now that all of you are here, let me ask again. How many of you were able to read that article? If you were able to read the article, let me see yes in the comment section. Now that all of you have joined. If you read this article, let me see yes in the comment section. Nobody read the article. Okay. I can't see anybody saying yes. All right, let's proceed. Okay, so this is embeddable implementation. So now that we have created an embeddable implementation, let's now look at how to create a component. Yeah, I shared an article in the last class and I asked you guys to read it. That after reading that article, you definitely understand everything about components, how to create a component and how to make use of a component. Okay, I'll share it maybe after the class. It's actually inside the Starknet Africa Telegram group. All right, so let's create a component. So please, if you still don't understand this thing, what I just did, can you let me know before I proceed? My goal is not to rush and finish. My goal is to help you guys understand this thing. If it's to change the way I'm explaining it, but if you understand it, I can proceed. Okay. No one is saying anything. All right, let's proceed. So this is embeddable implementation. Like I said, is the building block of components. So now let's create components and see how components work and how this embeddable implementation is the building block of components. So I'm going to leave this guy. Let me create a new project sharply. So I'm going to say services new. I'll say scab new creating components. Yep. All right. So guys, pay close attention. Pay close attention. Wow, 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 wow. All right, so okay, so components here, and I'm on this guy. So I'll open this guy and say close. Yeah. Okay. Yeah, let's go 1, 2. All right, so now we want to create a component. I'm gonna get rid of all of this. I don't need them. It's about to go down. All right, so how many of you are from the Solidity background? If you're from the Solidity background, let me see a yes. Solidity background, yes, 1. Please, 2, 3. 4. Please, faster, 5, 6. I want to see all those from Solidity background. 7, okay. All right, so the reason why I asked that question is because we are going to, the component we are going to create is something most of you are familiar with on the Solidity side of things. You know, the ownable component. You know, in Solidity, you have the ownable library that you import if you want to, you know, transfer ownership, check owner of like who owns the contract, you know, all of that. You want to renounce ownership. So that ownable library that ownable library is what we are going to create. So we are going to create a component that you'll be able to like transfer ownership, renounce ownership, and all of that. And you know, things like that, you need to embed it in your smart contract to make use of them. So that's what we are going to be creating. So I will move it pretty fast. So please make use of the chat if I'm moving too fast. I want to engage in time management. So first thing first, we are going to do what we call project structure and all of that. I don't know if you guys have done that before, but I'm sure you might have. So I'm going to create something called ownable underscore components dot Cairo, right? And I've gotten rid of this. So inside here, I'm going to do public mode ownable components. So what I just did here, instead of writing my code inside the lib, I created a file. I will write my code inside this file, and I'm exposing the file in the lib, because this library is the entry point to your contract. So once you create this guy and you expose it here, through here, anybody can see it. That's a high level explanation. So this is where I'm going to be writing my code. So if I choose to write the code line by line, we are going to sleep here today. So what I'm going to do is, I've written this stuff before. I'm just going to like get the code, paste it, and explain it so that we won't sleep here. What you need to understand is what I'm doing, not writing the code line by line. So I'll explain the code and all. So the first thing we are going to do, we are going to create an interface. Remember what an interface does. So we are going to create our interface, which is this guy. So the interface, we named it IOwnable. And the reason why this is complaining is because we are making use of a type that is not available in, like, it's not available in the Cairo standard library, so you have to import it. So I need to do use Starknet : contract address, right? That problem is solved. So now we have our interface. Our interface has the owner function. This returns the owner of the contract. It has the transfer ownership. This is when you want to transfer ownership to someone else. It has the renounce ownership. This is when you want to renounce your ownership, that you don't want to be the owner of the contract anymore. And it has this increase count. Yeah. So I just added this function for test purposes and all. But we can get rid of this. It's not really important. Okay. Now we have created. So one thing you need to understand, please let me mention something. If there's any other thing you don't remember this. Component looks exactly like smart contract. There are just slight differences, which I'm going to show you. The same way you create smart contract, the same way you create components, with just slight differences. So I'm going to point out those differences and why those things are important. So you see, the same way we have interface for our contracts, that's the same way we have this interface for our components. The same way we create public mode ownable component. This is how we also create our smart contract, right? The only difference now is in smart contract, you make use of Starknet : contract. That is what you do in contract. But here, instead of contract, you make use of components. Are you seeing the difference? Now, that is the difference. Now, The same way contracts have storage, components too have storage. Remember in our previous class, we were linking the storage of our contract to that of the component. So components too have storage, the same way contracts have storage. So we are going to create storage now. We are going to still flag it with the storage keyword. So storage, and we are going to say struct storage. And that's it. We're good. So now we need to add something. So let me just remove this guy. I don't need it. I don't need it. I don't need this guy. Why is this guy complaining? Okay. I don't need this increase count. I only use this increase count to test whether the component I created then was actually working. So I just needed to do a quick test. So that was why I created that increase count. We don't have contract address imported. That's why this guy is complaining. Yeah. All right, we have it. So you see that our storage has the owner variable. So this is what tracks the owner and everything. So now we need to add an event. So this event is to know when ownership is being transferred. The same way you have event in your contract. And you know, events in Cairo, if you want to actually capture the fields of events, you need to create a struct that contains those fields. So now we have this ownership transferred pointing to this ownership transfer struct. So we have to create the ownership transfer struct. So let's come here. We have to create a struct. Now this struct contains the previous owner and the new owner. So whenever you emit an event, this is what you're going to emit. And when you emit this, it's going to contain the previous owner and the new owner. The same way, if you were writing things like Solidity, you know you have when you create an event, you also pass in the fields you want to emit, sorry. But, you know, in Cairo, you have to create a struct and define the fields inside the struct and all. So this is the struct and the fields that the struct contains. So let's proceed. Then also, you can create custom errors. Now, instead of, you know, the reason why I'm using Solidity reference is because a lot of people that came from the Solidity background will be able to understand this. But irrespective of that, I still explain it for those that didn't come from Solidity background. So this is it. You know, in things like Solidity, you have custom errors and you have your require statement. So in Cairo, there's also something similar to require statement, right? And there's also something similar to custom errors, but not like custom errors the way it is in Solidity. So I'm going to show you the difference. For instance, let me go here and do this. Let me use this guy to explain what I'm talking about. For instance, I can come here and say assert that get caller address. No. Okay, assert that 1 is equal to 1. Else I will say invalid number. Right? Now, this is the normal require statement. This is your normal require statement. Assert that 1 is equal to 1, else you say invalid number. But I can still do something like this. Yeah. Hope this is gonna work. Will this work? Okay. I'm just trying to see. Let me create this guy. So paste this guy here. So I have a module called errors, right? So can I use this here? I can now say let me remove all these errors here, right? I can just say public const wrong number, right? And it's going to return a failed, and I'll say invalid number, right? So instead of using this here, I'll just do this. And I'll say errors, colon, wrong number. You got it. Yeah. Did you see that? Are you guys following? Did you see what just happened? So this one now is the custom error. The other one is the normal require, So here now you can create a module that contains all your custom errors. You can just easily reference the particular error you want to emit. So that's that for this guy. So let me remove all of this. Okay, I'm testing most of these things for the first time. All right, so that's that. Let's come back to this guy. So the reason why I showed you those that error stuff is because we make use of custom errors here. So I'll just paste this custom error here. So that's how we are flowing. Now we are done with our setup. What we did was we created our storage. In Solidity, once you create the contracts, all the spaces that are outside functions are your storage. But in Cairo, you have to create a struct, and all the spaces inside that struct will now be your storage. So we have created our storage. And we have also created our events. So this is the only event we have. And this is what we are going to be emitting in this event. And we have also created our custom errors. So what I'm showing you now is the standard way of writing contracts. The same way they tell you in Solidity, it's better to use custom errors. I don't think it's better to use, but it's just cleaner on this other side. So now let's move to the main thing. The main thing here is I'm going to move pretty fast. This is almost an hour, so I'll move a bit faster, right? So now the main thing is we want to now create our embeddable implementations. Please pay attention. This is the component. Remember I said a component contains one or more embeddable implementations. Now this is our component. Now we want to create the embeddable implementation. So see the difference. So we are going to say, inside here, we are going to say embeddable as. So whenever you're creating an embeddable implementation inside a component, you have to use this embeddable as flag, because it is the name inside that embeddable as that you will use to embed it in a contract. If I call this guy Casweeney, let's say I call it Casweeney. Okay, let's call it Casweeney. If I want to use all the functions inside this embeddable implementation, I'm going to embed it as Casweeney. So, but let's continue. So I'm going to use enable here, and down here, I'm just going to say implement enable, right? Enable implementation. And I'm going to say T. So we make use of generic here, T contract state here. Now, guys, please pay attention to this thing I want to explain to you, because if you don't understand this thing, you will not understand the reason why we were using component macro in our last class. The component macro, yeah, this thing we were using in our last class, this guy we're using in our last class, right? Now, I want to show you why we always use this component macro. So, pay attention. So, I'm going to do comma here, and I'm going to do plus has component into the contract state, right, of super. So the reason why we are using super is because we want to tie this particular interface to that embeddable. So it's going to implement all the functions that are in that interface. So super I ownable into component state, right, into the contract state. Okay, now we are going to open this. Why not all trades? Okay, yeah, that's correct. We are expected to get that. Okay, so guys, let's wait. Something is wrong here. I made a mistake. Yeah, it's supposed to be here. Yes. Okay. So guys, let me do this stuff and show you what is happening here. If you're confused, let me see your hands up. If you're confused, say yes, I'm confused. Don't say yes. If you're confused. Too. Yeah, I expect you guys to be confused. Now, normally, the way to go about teaching components, I would have just gone straight to teaching you how to make use of components without teaching you how to create components, right? But I'm trying to help you guys understand what is actually happening under the hood. So what is happening here is there's something called trait bound. Trait bound. If you have pen and paper, write it. There's something called trait bound. So this stuff you're seeing here now, you see this plot you're seeing here, this is a trait bound, and I'm going to explain what trait bound is. So what you're saying is, in these places, we want this ownable implementation to take in any kind of type. Remember, this is a generic. This can be any type. But any type that you're passing through this ownable implementation must implement a trait that has this has component. Let me explain it. So I wrote that thing in this article. So let me use the example I used in the article to explain it, so you understand. It's here. I know where it is. Aha. So I said something here that this line 44. So line 44 is defining an implementation block that passes a generic T contract state with a trait bound as component. Now, the T contract state is a generic type passed into this guy. This can be any type since it is a generic, but the additional trait bound, which is this guy, specifies that the generic must be a type that implements as component trait. I know it sounds like a lot. Yeah, I acknowledge that fact because most of you are confused. Let's explain it in simple terms. A trait bound is like a requirement that a type must meet before it can be used. A requirement a type must meet before it can be used. So imagine you have a function that needs to work with different types of objects. In our case, that object is T contract state. You don't want it to work with just any object. You want it to work with objects that can do certain things. Things like has components. This is where trait bounds are used. Are you guys getting the gist? Yeah, I'll share the link. So on line 44, the plus has components is saying that this implementation will work with any T contract state, but only if the T contract state has the capabilities defined inside the has component trait. So this is another explanation I use. It is more like saying I can work with any kind of cake. the cake is a T contract state. But only if the cake has icing and the icing is the hash component. That is what this thing is just saying. So you can pass in any type here, but that type must implement this trait, and the trait it must implement is the hash component trait. Now, anytime you define this component macro inside your contract, it automatically implements this guy. That is why this thing is added here. Are you guys following? Yes, it's complicated, but if this is not something you rush into. Yeah, I know when I was studying about this guy, I took time, I took good time to study about it. So in your contract, anytime you do this component macro, it is generating this guy, it is implementing this as component trait under the hood. That is why it's not complaining. The moment you don't use this component macro in your contract, you won't be able to embed this guy. So that is what this thing is saying. So it's just like saying you can have any friend, but your friend must know how to write code. So that any friend is this guy, and that condition that it must know how to write code is this guy. Does it make sense? Is it making sense? If it's making sense, please, guys, just answer. Say yes. Yeah, it is only component macro that you can use. That is how it is. It is only component macro that you can use to make sure your contract implement that as component trait. And let me give you a secret. So guys, let me give you a small secret of how I learned Cairo. Now, if you want to be very good with Cairo, write all the contracts you've written in Solidity. If you write Solidity for the Solidity guys, write all the contracts you've written in Solidity with Cairo. By the time you get to the 6th contract, you will know Cairo like the back of your hand. And for every contract you write, make sure you write the test, because it is the test that will stretch you, not even the actual writing of the contract. So that's just by the way. Now, this is how we declare our embeddable implementation inside a component. You see that it is different. Here, when we're declaring it just on standalone, this is also an embeddable implementation. But here, it is not inside the component. But here, inside the component, that is why we have to do it this way. All right. So now we have declared it. Let's implement the functions in this trait. So I'll just copy the implementations and pass it and paste it there. So you guys will see this stuff. Okay. What is going on here? Okay. All right. So now, what we just did now is we have implemented. Oh, yeah. This read, I've not added that. For you to be able to read from stage, you need to import something. So let me quickly import it so that we have access to reading from state, from storage. I call it state. So I'm going to bring this in here. So this is it. So if you want to be able to read or write to storage, you need this. You need to import this storage pointer read access and storage pointer write access. So this read, that's the only way you'll be able to read and write from storage. So now this is 0, this assert only owner, all of these are internal functions. So now this is the embeddables that we want to be external when embedded in our contract. So now let's create the ones that will be internal functions that shouldn't be exposed. So I'm going to do the same thing here. I'll just copy this guy, paste it here. And this time around, I'm just going to call it, I'm going to call it internal implementation. So guys, paste it here and do this. So this is it. In this guy, you don't make use of embeddable as, you just make use of generate rate. So that is what you just use here, because this is an internal implementation. It's just like having your internal functions or your private functions in Solidity. So I'll just copy all the internal functions and paste it here. So these are all the internal functions we need. Now get caller address, caller is 0. I'm going to add all those things. So get caller address is the same thing as msg.sender. So this get caller address, what is returning is the address of the person calling a particular function. In Solidity, that's what your msg.sender does. So I'm going to import it here. Right, get caller address. Now, there's a way to check if an address is a 0 address. So I'm going to also import that here as well. I used it in the other guy, in the other contract we wrote the other day. I'm going to import it here. So with this, you can check if an address is a 0 address. So you see that everything is now clear. So watch, this is our internal functions. So it is inside another embeddable implementation. But this one now, we didn't use embeddable as here. We just made use of generate rate because we want this to be an internal implementation. And everything remains the same. This, and this. So, and here we go, we have the initializer, which initializer just works as your constructor. We have our assert only owner. This is just to require that the person calling a function is the only owner. So it's a helper function. And we have this helper function too to transfer ownership. And with this, we have completed our components. So you might not understand this now, but I will advise you to watch this recording because I'm moving very fast just to keep up with time. I'll advise you to rewatch this recording. I'll advise you to read that article. I didn't mean any of you read the article. You would have gone home with a bounty, but none of you read it. So let me continue. So this is how to create a component. So just for testing purposes, let's now see if we can use this component that we have created. Let's see if we can use it the same way we use the component in our last class on Tuesday. So now I'm going to create a new contract. Now I'll call it a contract. I'll call it test. Let's just call it using ownable.cairo, right? All right. So this using ownable.cairo, what we are going to do now, we are going to just create our contract. Now, guys, pay attention. You see that it's the same thing. To create a contract and to create a component is the same. The only difference, let me point the difference again. The only difference is just one, you're making use of components here, and two, the way you're declaring your implementation block is different because here you're making a generic. The reason why you're making this generic is because you're passing in the contract state of your contract here. So you have to make this a generic. And you also have to make sure that the contract implements this as component trait. That is just the difference. Every other thing remains the same way you do it in your what is it called, your contract. And here, instead of using contract state, you're using component state because this is not a contract state, this is a component. So you're making use of component state. instead of contract state, and you also pass your generic there. One thing, I was telling somebody that Cairo is easier than Solidity, and the person was arguing. Cairo is easier than Solidity in the sense that once you know Cairo, you know Cairo. Anything you're doing in Cairo, you already know the outcome. There's no EVM might misbehave tomorrow. Somebody might use low level to steal funds from you don't do that in Cairo. The only thing is that Cairo syntax is a bit verbose and all of that. Solidity is not verbose. Cairo is verbose. But Cairo is straightforward. Once you know it, the ecosystem, like what the language contains, is not too much. So you can know everything about Cairo if you write a lot of Cairo. So if maybe you encounter error and somebody tells you, oh, I'm having this issue, you can already tell where it's coming from, because if you're writing Cairo well enough, you must have encountered that issue too. So it's not hard. And another thing is, it's kind of harder to read a Cairo code than to read a Solidity code. But it's easier to write Cairo than to write Solidity. You always second guess every line of your code in Solidity, but for Cairo, you don't. All right, so let's continue. Let's now move over here to use our guide. I'll say Starknet : contract, right? And I'll now say mode. I'll just say, what do we call this? Using ownable. This is now a contract. So we want to use the ownable stuff we created, right? So the next thing we are going to do, we need to import. Remember, guys, in our last class, I gave you guys how many steps to make use of components. Please list it out for me. Let's follow those steps and see if they work. In our last class, I gave you guys steps of making use of components in a contract. Number one, the first thing I said is to do what? First thing is to do what? So this one now, we are not installing it because we have it already in our, we are not installing the dependency because it's already, we created it inside our package. So we are not installing it from OpenZeppelin. No, linking is not the next. The next is to import. So to import, we are going to say use create. Inside this create, we are going to say ownable component, right? Is that the name we called it? Yeah, ownable component, : What is the name of the component? Let's check here. The name of the component is ownable component. So we'll copy it and paste it here. If it's wrong, it will tell us. This can be any name. If I come here now and change this name to Casweeney component, watch. If I change it to Casweeney, I'm only doing this so that you understand. If I change this to Casweeney component and I come here, so sorry, I've not exposed this guy. Let me expose it. Public mode using So now this guy is creating error because I've not created storage. So let's say hash this storage, and we say struct storage. Yeah. So you see that it's complaining now. But if I copy Casweeney component and paste it here, it's going to work. Have you guys seen it? So that can be any name. It can be any name actually. So let's change this back to ownable component. If you save it now, this one will complain. This is why I like Cairo, just giving me rust feeling. So we have this guy now. Now that we have imported it, what is the next step? Linking. So let's link it up. So to link it, and this linking, what this linking is doing, this linking is implementing the hard component trait in our contract. So I'm going to say the component macro. First thing is the path. And this is the part, I'll pick this guy up and paste it here, right? Now, second thing is what? The name we want to use in the storage, right? So I'll call this guy ownable in my storage. And here I'll say, I can call it cast ownable. So I'm making these changes so that you guys know that this can be anything. And I'll now say this ownable component here, storage. Storage is going to throw an error. Why is it throwing an error? I didn't make storage public here. So if you point it here, it tell you item is not visible. So I didn't make it public. So I'm supposed to make storage public. So I'll make it public. Yeah, and we're good. So it works. So now what I'm going to do here is I'm going to say storage is equal to cast ownable. That's the first thing. Then the next thing I need to do is I need to link the events, right? So event, let me create an event in this contract. So I'll just come here. Event is an enum. I'll just open this guy. I'll say events, right? And inside here, I'm going to say enum, call it event. And inside here, I'm going to call it cast. So I'm always adding cast so that you understand that it can be anything. Cast ownable events, right? So this is going to be pointing to ownable : event. Okay, yeah, event is public, right? So now I'm just going to copy this event and link it here, and that's it. But remember, I said something that, see, this guy is crying. Who can tell me why this guy is throwing an error? Somebody type it. Fastest finger. Fastest finger. We have an error on line 5. Who can tell me why it's throwing that error? Oh, no fast finger. Okay. Let me just fix it. So we have, nah. That's not the reason. We have sub-storage. I mentioned it in our other class. Sub-storage into V0, right? So, and also for this event, we need to add another trait to make sure to let it know that it's an event. And we also need to add something called flat here. So, yep. All right. So this is the linking. This is the step 3. So what's the next thing to do? Somebody, fastest finger. Fastest finger. You guys are not fast, new. So now, we want to embed now. So now to embed, I'm going to say implement ownable implementation is equal to now ownable component : this is where we now want to call the name of our embeddable. So the name of our embeddable here is what? Ownable implementation. So paste it here. And this is where we now pass the actual contract state. But why is this guy? It's not visible. It's not visible. It's not visible. So I need to make it public. Am I supposed to make this public? Public. Okay, yeah, it works now. So you see that we have embedded it. If we change the name of this embeddable here, this embeddable as, if we change it to, let's say, Mojid embeddable, yeah. Let's change this to Mojid, right? This is supposed to throw an error. So we are supposed to do embeddable as Mojid here. It's supposed to throw an error. My compiler has not picked it. This place we use embeddable as Mojid. Supposed to do this guy. So just to check it out, let me compile to see. But it's expected to fail. Scar build, yeah, scar build. It's expected to fail. Why? What's popping? Enable component. Enable implementation. No. Oh, why? Is it that this guy, this is what is embedding? Wait till I'm coming. It looks like this is what is embedding. Mojid. No, this is not it. Okay. So it looks like this is what it is embedding. I'm coming. Oh, I see. Then why is this name? Let me see something. Enable info. No, this is not supposed to be like this, though. I don't know why this is not supposed to be like this, but let's see. Let's just continue. I want this one shock me. Okay. Let's go. Let's just take it back. All right, enable info. Okay, so looks like what it is actually embedding is this guy. And since this guy is what is taking the generic, this is what we are embedding and we are passing in the generic here, right? And we're good. So, but note that all the functions inside this guy now, inside this place, they are not public. So the only way to make them public is to add this attribute to it. And once you add this attribute to it, you've made it public. And why are we having this error? Trait not found. Trait not found. I'm coming. Sorry. Trait not found. I know what I was saying now. This thing want to shock me. So, yes. So this is it. You see that? Let me do this guy again. So I want to Mojik info. So this is what you're embedding. So I want to. So this is what you're embedding. Are you guys following? What you have inside this embeddable as is what you're embedding, not this guy. This thing was misbehaving. This compiler is, something else. Now making me look like I don't know what I know anymore. So what you're embedding is actually what you have inside this embeddable as, not this guy. So now we have it. So the next thing we are going to do is embed the internal implementation. So for the internal implementation, we don't need the to add the API embed v0 to it. So we just do enable internal implementation, right, equal to, we get the ownable component, colon. So now, this guy, since this guy doesn't have embeddable as, you can now use this guy directly. So that's the difference, right? So you pass in your contract state here, right? So, and that's all. So like this now, we have embedded the component we created inside this using ownable contract. I wish, so in our next class, which is going to be next week, when we'll be dealing with testing, we are going to do all of this. But then again, guys, for your own learning purpose, deploy this contract. You see this contract called using ownable. Deploy it and check if you're going to see all these functions in the contract, like to interact with it. Deploy it and check it. So I will need you guys to give me feedback. It's going to be part of your assignment though. So you need to deploy this contract and check if these functions are available for you to interact with it on stackscan.io, or what's the other one? Yeah, stackscan.io. I've forgotten the Voyager, yes. So, all right. So this is about creating component and using a component. Any question before we fire down? We still have one small thing to do, guys. Small thing. If you have any question, please ask. Oh, this was a lot. Hi, guys. Are you guys with me? If you're with me, say yes. All right. Yeah, I can see Obiamaka, country cousin, Mojid, Cindy, Vanshi Krishna, Abdul Azim, yes, Hamid. Let's go. Let me know the people that are still with me. Yusuf, Mr. Weeks, Chidera. Where is Ebuka Moses? Where is Leonard? Where is Nathan? Oh, sorry. Where is Truth? Where is Favor? Who else? Okay, let's continue. All right, so this is basically how to copy. This is basically how to create a component and how to use a component. All right, so now we are going to write a small contract, very fast. I'll be very fast with it. It's just a very basic contract. And we'll just write the contract and we are going to upgrade the contract. And in order to upgrade that contract, we are going to make use of the OpenZeppelin upgradable component. So very fast. I'm going to close all of this. I'm going to close this guy. I'm also going to close this guy. We don't need them anymore. All right. So quick one, back to this guy. I'm going to scaffold a new project. And we have less than 30 minutes. So I'm going to move like Usain Bolt. So I'm going to do scab new, what's the name? Yeah, token sale contract. So I'll scaffold a Foundry project here. Quick. Yep. And I'm going to cd into, let me clear this guy and zoom in. I'm going to cd into token sale, and there's something I wanted to, okay, I'll explain it in this guy. cd into token sale and code. There's something I wanted to show you guys. Yeah. So let's go. 1, 2, right? And let's get rid of this guy. So in this contract we are going to write, you will learn how to structure your project, which we did before, but you learn a more complex project structure here and all. That's how I like structuring my project. So that for those of you that will continue into contributing to only DOS. When you see a huge project with the structure, you already know what's happening. So you're learning how to make use of component and also structuring of project at the same time. So quick one, I'm going to create a folder for my interfaces. I don't want to be using interface in the same place. And I'm also going to create, I won't use mocks here. I won't use mocks. I only use mocks if maybe I want to start testing. All right. So inside interfaces, I'm going to create IERC20.Cairo. And I'm also going to create the interface for my token sale contract. I'll call it token sale.Cairo, right? Pretty fast. Then I won't make use of lib. So I'll just create a file called token_sale.Cairo. Yeah. Now, pay attention. If you want to, so now let me quickly do public mode token sale. Oh, no, not here. Inside my lib is why I want to do that. In my lib, I'll do public model token sale. So my token sale file is available in my lib. Now, if you want to make this interface, everything inside this interface available here, first thing you do is you create a file with similar name as that folder. You call it interfaces.Cairo, right? Now, this interfaces.Cairo, this file is what you're going to expose here. You're going to say public mode interfaces. That is what we exposed here, this file. Now, you want everything inside this folder to be available. So the first things we have is, we have the IERC20. You now do public mode IERC20 here, and you do public mode token sale here. So this is the flow. Inside this interfaces file is where you're exposing the things inside the interfaces folder. Then inside the lib is where you're exposing the interfaces file. So that's the connection. And with that, we are good. So let's proceed. Fast. Let me populate this IERC20. I'll just copy this guy here and paste. It's the same IERC20 interface. And we paste it. The same thing. You have the name, symbol, decimal, total supply, balance of allowance, approve, transfer from, and mint. Same. Now, in our token, still, I'm only going to implement just 4 functions. This is a very simple and straightforward contract. So, no, we don't need this guy first. So this contract is going to check if a token is available, deposit into the contract, buy a token. That's just what it's going to do. So that's it. And now let's go to the main contract. So this token sale contract, I'm going to start by, let me just look at this guy so that I don't want to waste so much time on this guy. So I'm going to pick this guy from here and I'll put it here. This is our attribute. So I'll now say mode token sale, which is the name of our contract. Now you have to create a storage for it. So I'm going to say hash into the storage guy. And inside this guy, what is wrong with this one? Inside this guy, I'm going to create a struct. And I'm going to call it storage, and we're good. So now we have our storage. If you want to create a token sale contract, first thing first, you need to, okay, we are creating a token sale contract, which means people can buy token. We need to know, we need to specify, okay, if you're coming to buy a token in this contract, this is the token you're going to use for payment, because this is not Ethereum where you can say you want to receive Ether. So I want to specify the payment token I will receive for payment. So to do that, I'm just going to say accept. Let me just pick this guy from here. I don't need to write everything. So accepted. Oh my goodness, I'm moving fast. All right, accepted token, and this is going to be of type contract address. So it's going to throw an error. So we need to import contract address here with use Starknet : contract address. We're good. Now the next thing we need is we need to specify the price of the token, and our contract can support buying and selling of multiple tokens. So for us to support multiple tokens and their prices, this is where making use of stuff like mapping comes in. So we have to map the address of the token to the price that that token will be sold for, right? So that's where mapping comes in. So I'm going to say token underscore price into map, and in mapping we make use of this what is this called again? Less than and greater than. So I'm going to say the key. This is the key to our mapping, which is the contract address, and it's going to return a U in 256, right? I was supposed to put a comma here, right? Comma here again. So this is this guy. But now we have not imported the map stuff. It's not part of Cairo standard library. So I'll just pick it up from here and paste it here. So we don't waste a lot of time. So for us to be able to use mapping, we have to import map. Now this one, we need it to read from storage, and we need this to write from storage. This one, we need it to manipulate mapping, this storage path entry. If you want to do dot entry and you read from a mapping and you write to a mapping, for sale, right? The tokens that are available for sale. So I'll say tokens underscore for this. So see, this contract is not a use. You don't use this contract on mainnet. I was just playing around before class and I said, let me just come up with something we are going to use, right? So don't use it on mainnet though, if not. But they won't hack it although, but it's just that the conditions I use are not really feasible, relatable, right? Contract address and you in 256. Tokens for sale. Okay, yeah, tokens for sale, contract address and you in 256. So this is supposed to be tokens available for sale. Available for sale. Yes, that's supposed to be the name. So you want to know, okay, if maybe I want to sell USDT, how many USDT is available in this contract for sale? How many Shiba Inu is available for sale? So you pass in the contract address and it will return the available tokens that is in the contract for sale. So with this, we have gotten all we need. So the next thing we want to do is we want to now implement our constructor. So I'll just copy it, please. No, what's the time? Oh, shit. I have 17 minutes. Okay, let's go. 17 minutes, 17 minutes. Okay, so let's keep this guy here. So this is our constructor. Our constructor is taking in the address of the owner and is taking in the accepted token, the token that I want to accept as payment. That's what it's taking. So we do self. Self means me, myself. So this guy is inside this module, and it wants to access the storage of this module. So it's saying myself, me, owner inside me, which is this guy. So I want to write into the owner. So it's writing this guy into the owner. Then you say self accepted token, still me, this guy inside my storage, write this guy to it. So I'm writing this nigger to it. All right, so we good. That's about the constructor. So let's proceed to the implementation block. So I'm going to say token sale implementation, token sale implementation, which is of now we need that interface, our interface. So there's something I wanted to show you. There are two ways to import something in your project. You can use the name of the project, the name of the package. Use this colon interfaces colon iToken sale colon iToken sale. Now, but mind you, anytime you make use of this pattern, if you change the name of your project inside here, let's say we add another E here, it's going to throw an error. Are you seeing it? It's going to throw an error. So what is the safest way? The reason why I'm showing you this is because of testing. In your test, if you import using this, anytime maybe you decide to change the name of the project, you have to go back to your test to change all your imports. But if you use create instead, you're not going to get that error. Even if you come back here and remove this E, you're not going to get that error. So create is saying this package, this particular package, whatever the package is, pick this thing from anywhere it is in this package. But when you use the project name, you're tying it to this particular project. Any other, when that name is changed, all your imports will fail. I just wanted to mention that. So let's proceed. So now we are going to do of this guy into, this is where we pass our contract state, right? So we pass our contract state here. Yeah, and we do this. So the complaint now is telling you that you have to implement all the functions that exist in that interface. And let's look at our interface. This guy, we have 1, 2, 3 functions. Let me space them out so that the code can breathe. All right, we have this guy here. So what I'm gonna do, you guys already know how to write contract. Is there any need for me to start writing the contract, every function? Is there a need? Respond, please. Guys, make use of the chat. Respond. Is there a need? You already know how to write contract. The goal is just to show you how to upgrade, right? Guys, respond now. There's no time. Okay, let's proceed. I will choose my own answer. Okay. So nobody's responding. Are you sure these guys are still in this class? Or everything is just so complex? Are you guys? All right. So I'll just paste this guy here. So this is the function to, okay, I think I should just implement this quickly, right? Okay. So I was saying something before that you make use of interface for two reasons, for implementation and for interaction. Now, this place where we are using this interface, we are using it for implementation. That means we have to implement all the functions that exist in this interface. But there's another way to use the interface, which is for interaction. And it is different from how it is in Solidity. Here, you are going to import the interface dispatcher. So anytime you create an interface, the Cairo compiler under the hood creates a dispatcher for you for that interface. It is the dispatcher that you use in interacting with an already deployed smart contract. So I'm going to do use create interfaces IRC20 : Now I want to make use of IRC20 dispatcher. So here, anytime you import a dispatcher, you need to import the dispatcher trait. So I'm going to add the dispatcher trait here. So to do this, I want to check my balance. the balance of this contract. And all I'm going to say is fn, pick this function. Let me just get this guy here. Right? Pick this guy here. And we now want to get our token. So let token be equal to, remember, we use dispatcher to interact. So I'll say dispatcher into contract underscore address, right? And we want to check the available token, right? Check available token, check available token. So we want to do, okay. The token we want to check, we should be able to take in the address, token address here, right? And we call this contract address. This is not part of the interface, so I'm going to add it to the interface. So let's come here, this guy, I'm going to add it to this interface now, right? You see the code I wrote earlier, I'm modifying it in the class. So now we want to check if this guy has the token, right? So what we want to do is, yeah, we are going to paste this here. Sorry, not this. Token address. Yeah. So we end this. So what we want to do is, no. What's this guy doing here? Yeah. So yeah. Let's token. Oh shit. Yeah, this is correct. This whole stuff was looking too confusing. Aha, this is what we need. Yeah, correct. So now, what we are doing here is we want to get the token. So we are interacting with a token that is deployed on chain. That is why we are passing this address here. I want to get the balance of this contract for that token. So what I just want to return, I'll now say token dot balance of get contract address. So we have to import this here. Sorry guys, this is quite fast. So we do this guy. Yeah. So what this is doing basically is, we want to return the balance. So this token we are passing now is, let's say we want to buy a token. We want to check whether this contract actually have that token for us to buy. So that is what this is returning. It's returning the balance of that token for this contract. So this stuff you're seeing here is the same thing like address this in Solidity. Let me quickly do that here. So sometimes I like doing this. I'll just say, let this address is equal to this guy, right? Then I'll just say balance of this address. So it makes it clearer, right? And remember, you don't put semicolon when you're returning, or you can do this and do return here, and we're good. So it's the same thing. So let's move to the next function. So the next function is, this function is long. So we are just gonna copy this guy and paste it here, right? So this one is making use of get caller address. Get address does the same thing msg.sender does. So I'm just going to import it here, right? Does the same thing msg.sender does. So this one says token sales. Okay, yeah, I get. We called it token available for sale here, and we pasted it here. Oh shit. Pick this guy, bro. Token available for sale. Paste it here. Yeah, we're good. So this function, what it does, it's only the owner that can call this guy. That is why you see this assert there. Assert that the caller is self.owner.read. So I can just change it to unauthorized, unauthorized, right? Yeah. So only the owner can deposit token into this contract. That's my implementation. So when you want to do yours, you can make it better. So the next thing we want to do is we want to buy token. So the buy token function is just this guy. So token for sale, I'll just pick it here, token available for sale, update it. Yeah. So that's what this guy is doing. So it's checking to ensure that, so what I'm doing basically here is you cannot buy an amount that is more or less than the available amount. That's why I say don't use this contract on mainnet. I'm just creating something. The main goal of this contract is to show you how to upgrade it. It's not about the code here. So I'm getting the buyer's address, then I'm getting the payment token and the token to buy. Now, buyer balance, balance of the buyer, buying price, I'm getting the price for that token and all. I'm asserting that the buyer balance is greater than or equal to the buying price, as I'll say insufficient. Then once this check is passed, I'll transfer the payment token from the buyer to the contract, the buying price. Then I'll transfer the token to buy from the contract to the buyer, and I'm transferring everything, all the balance. So to make this readable, I can just say, let total contract underscore balance be equal to this, right? Then I'll now transfer total contract balance out, and that's it. So this is just a small, this is just a play contract, just to show you guys how to upgrade. Now I'm going to move very fast because this is something we have done over and over again. So to upgrade this contract now, I'm going to go to the scap.2ml file, and I'm going to add OpenZeppelin dependency there. So this is the OpenZeppelin dependency. I'll just copy it and add it here. So I told you guys to make use of a component. The first thing to do is add it to quick question though. What if you have multiple tokens to sell? See, the goal of this is not to teach you how to write smart contract. The goal is to teach you how to upgrade a contract using the upgradable component. I just wrote that contract just to show you guys this stuff. When we want to write smart contract, we'll sit down now and analyze logic line by line. But for now, we are not. The goal is not to teach you how to write contract, but to teach you how to upgrade a contract. All right. So I've added this OpenZeppelin dependency here, right? So this is it. I've added it. That's the step one. Install the package you want. Then step two, import it. Import the component where you want to use it. So this is our token sale contract, and I want to use the components here. So what I'm basically going to do, I'll just say use OpenZeppelin. Sorry, let me copy this. Don't need to type it out again. Where is my guy? Where is my guy? Where is my guy? Yeah. So I'm just going to say use OpenZeppelin upgradable components, right? Then this is step two, where we are importing it. Step three is to link it. So to link it, we are making use of the component macro that also implements the has component trait. This is it. So the component macro will specify the path, which is this guy, the storage upgradable, the event upgradable event. So now inside the storage, we are now going to add this here and make it to copy this component, paste it here, colon, storage, right? There's supposed to be a semicolon here. So somebody is shouting Cairo Mapamina. Cairo is not hard. just because everything is coming in at the same time. That's why. So let's link the event as well. So I'm going to create an event. This is the event here. The same thing. This is the name of the event. To be the same with here, right? And this guy, and all. Why is this guy saying train error? Okay. Please, who can tell me why this guy is throwing error? I've asked this question before. Fastest finger. Soft storage, yeah, that's good. So you need to add the soft storage guy. Mojib, you were the one that gave me wrong answer the last time and you still didn't get it. Eh? Okay, let's proceed. All right. So the reason why it was showing error is because of the soft storage. Can you compile? Let's move on. What's happening here? It's the same name now. Storage upgradable, yes. Soft storage flat. This should be my compiler. So now we have linked it. The next thing is for us is to embed. So let's embed it. And the upgradable component only makes use of an internal implementation. You don't need to expose any function. So all we just need to do is embed it here. So this is where we are embedding. Implement this guy equal to the upgradable component internal, and we pass the contract state. You see, this is now this error is going out. So we have done this. Now, doing this, the upgrade function in the component. So let me quickly show you the component. The upgrade function in the component, this is it, upgrades, this guy, interface. No, not interface, sorry, upgradable. So this is the component. The component only has an internal function, embeddable, and this is the function to upgrade, right? So what we just need to do now is we need to create an external function and make it only owner, so that it's only owner that will be able to upgrade. So let's go back to our interface. Sorry, guys. I know it is a lot, but bear with us. There's no other way. So inside this guy now, we are going to, let me get it from here. So we are going to get our upgrade signature and paste it here. And we are making use of class hash, which is this guy. Now, guys, please, hope you guys remember that in one of your classes, they told you how the Cairo VM works. So the storage is in the contract, but the implementation is in the contract, the class hash. So which means to upgrade a contract, all you just need to do is change your class hash. The contract will have the storage, but the implementation will be in the class hash. So if you just point your smart contract to a different class hash, you've upgraded it. So the new implementation will be there and the storage is here and all of that. So that's just what upgrading contract in Cairo is all about. So I've added this upgrade function. I'll just come here now, inside here, and I'll add the function here. So the upgrade function here, what it basically does is you just do fn upgrade, right? Sorry, fn or upgrade, and it takes in ref self contract state, right? And it takes in the new class hash, and that's all. So what you just do, you assert that, right? Get caller address. Remember, get caller address is the same thing as MSG just said that. is equal to self.owner.read, right? Else you tell the person unauthorized caller, right? You end this guy. So new class hash. Oh, sorry, I didn't put the type. So the type is supposed to be class hash, and I also need to import it here as well. Yeah, you should be good this month. All right, so the next thing we need to do now is self dot. With this guy now, we can access all the functions that we embedded. I can call this anything. Let's just call it anything. And here, I'll change it to anything as well, right? So if I come down here, I'll now say self.anything.upgrade. And inside this upgrade, all we just need to pass is our new class hash, and we are good. This should be good. This should be good. This should be good now. Yeah, that's good. So this is it. Like this now, we have upgraded this contract. So let me explain how this works. Maybe you didn't remember what you were taught earlier. In your previous class, you were told that in Starknet, before you deploy a contract, you declare it first. Now, declaring a contract means like you're pushing the implementations on chain, and it's going to return a class hash. When it returns that class hash, deploying it now means you're now tying a contract address to that class hash. So anytime you make a call to that contract address, it makes the implementation is in that class hash, while the storage is in the contract. So if you want to upgrade a contract, all you just need to do is when you finish writing the new contract, you declare the contract. It's going to return a class hash. You copy that class hash, come to this upgrade function, and you upgrade. It will just update that contract. The contract will now point the implementation to the new class hash, and that's all. That's exactly what is happening here. Does that make sense? So our time is up. I did a very good job with time management. Just 8 minutes past 8. So yeah. And that's it. Any question? Any question? There's something else I wanted to show you guys, but time has gone. But let me just mention it. There's a difference between using this assert and using the one without this macro. Assert without a macro, expect a felt as the statement. Assert with a macro, expect a byte array as the message. So if you use assert with macro, you're going to wrap it with double quotes. If you use assert without macro, you're going to wrap it with single quotes. That's all. So thank you very much for staying through to the end. Some of you might be confused. I understand pretty well. The good thing you do for yourself is to rewatch this video, read the article, and practice. The content is here. Take it slowly, watch it, do it. As you're doing it, it will make sense. But for now, everything is like looking like a lot, and I understand. It took me like, I think, up to 2 days to study and really know how component works under the hood. And that was why I had to write an article for it, because I know a lot of people will get confused, like playing around it. So watch the video again, read the article, and I also told you guys that the best way to learn Cairo is to rebuild most of your Solidity contract with Cairo and write tests for all of them. If you do that, take like 2 weeks, in your 5th contract, you will know Cairo very well and ask questions wherever you're confused. And yeah, that's all from me for today. Thank you very much. And over to Sarah.
Thank you so much, Casweeney. Thank you. Well, I don't know if you guys have questions for him before we close the call. I mean, he even had a bounty for you guys. I think, I don't know, I don't know. I think Mojid said he went through the article, but he didn't say much, right? Kasuni, what was expected of them to do at least? Let somebody win the bounty now.
Okay, well, the bounty was basically it's a $50 bounty, so I wanted to send like stack tokens worth $50 to the winner. The bounty was basically I wanted to know anybody that read the article that could I was like, okay, I read the article and I pretty understand how component works and all of that. Then that's all. But they just went through it, but they didn't really read it and all of that. So that's it. And there were other questions I asked intermittently in the class. I was expecting somebody to actually answer, but I wasn't getting the kind of, and these were things I've already spoken about, like the sub storage stuff, all of that. But I wasn't getting fast response, and these were also opportunities to get bounty. You get, but then again, that's by the way. Akin, you did not answer. You did not read the article, bro. So yeah, that's it.
Okay. Thank you. So you guys have just missed $50 bounty. Well, you guys should make sure you go through the video, go through Tuesday video again. If maybe you are confused, make sure you read the article. You can set out a day to go through these things. Even this recording, the submission form for the assignment will be out by tomorrow. So you know what you're going to be doing as homework for this week, right? Ensure you go back to these recordings. And if there's a point where you get confused or you have questions, please, Casweeney is on the group, is on the Starknet Africa group. There are other persons that will also be available to answer your questions. Please do not hesitate to ask questions. Please, we want to make sure you make it to the end of the boot camp. So let us help you, right? Let us help you. So I don't know. Is there any question for either myself or Casweeney before we move on? Okay, Casweeney will also be the mentor for the next class. He will be taking us through writing tests for your Starknet contract. So
yeah, I wanted to mention that. So the next class, come prepare, most of the things you have written, I don't test contracts. I don't deploy contracts and test them. I write tests for everything I want to see in my contract. Everything I write tests for them. I've never used what's it called? I've never used SNcast. I've not used it before. I don't even know how to use it. So I write tests for all my functions very well. So we are going to be going into testing, and most of the contracts we are written, if maybe we're writing tests, I would have written tests for this token sale, and you see that it's actually working. So we are going to write tests for a lot of contracts. So come prepared. That it won't be as complex as this, because test is something very relatable. Yeah. So I wanted to mention that.
Thank you, Casweeney. Thank you. Okay, what is TDD? I don't know what that is. If that's a question, wait.
Test-driven development.
There's okay. Is it a question? Is it asking you that question?
No. So the test-driven development is basically you write tests that are failing. Then when you start writing the code, you write the code so that the test will pass. No, I write my contract first and I write tests later. Thank you.
Okay. So guys, any other question before we end the class? Any other question, or if you have any concern, anything at all, please make sure you do your assignment. And if maybe time permits, I don't know, your tutor might probably, I don't know, go through maybe like what do we call it? Answer to the assignment, yes. Yeah. All right, if there are no more questions, thank you so much, Casweeney. It was so the session was so insightful and amazing. Thank you so much. Until we see next week, do have a lovely weekend, and you guys should not forget to drop your questions, your concern, every other thing on the Starknet Africa Telegram channel. Yeah, we're always open weekends to answer your questions. Okay, so guys, bye. Have a great night rest. See you guys next week. Bye.
Bye, everyone.
Bye.